Morning, ladies and gentlemen. My name is Joshua Olusegun Ajitomobi. I'm your resource person for this training on intermediate data analysis using R. Let's start by looking at some things that we have to cover. For this first day, we'll be looking at how to clean our data and make some description of the data sets that we want to use. We shall quickly look at anatomy of statistical analysis. From there, we move to how to enter our data directly in R. And in case we have our data in Excel, Stata, SAS, or in some other spreadsheet, then we are going to go through how to import the data, then how to clean the data, specifically considering how to rename variables, how to select variables of interest, how to use subset of our observations, recoding, and how to create a new variable. And we shall be rounding up by looking at descriptive statistics. In terms of anatomy of statistical analysis, generally we start with the raw data, but the raw data needs some level of cleaning before we can use it for data analysis. And the process of getting the clean data involve technically correcting some information. This may call for data imputation in case we have some missing data. Sometimes we have to check the data for normality of the observations. You look for duplicates. Maybe peradventure you have to rename some variables. You may want to arrange in ascending or descending order. In case you have quite a lot of variables, then you may want to limit maybe your data to few variables of interest to you. You may also want to use a subset of the observation. You have to ensure that all these are done. After fixing all these problems, then you end up with what is called consistent data. So you don't use raw data for analysis. You fix the problem with the raw data. That is what is called data cleaning. Then by the time you obtain the consistent data, that is the one you will use for your estimation. Then after the estimation, you will obtain some results, whether descriptive results or some inferential statistics. Then you have to format your results, that is format the tables, depending on maybe if it's for a journal, for instance, the journal will have a format. And if it's a project, definitely the institution also will have a kind of format, so you have to format the results. Peradventure, before formatting, you check the results, maybe it's consistent with theory. If not, then you have to go back again and still look at whether the problem comes from the data itself and so on. So this is the process that we normally go through when carrying out statistical analysis. From here, I think we can go straight to our RStudio. So I want you to launch your RStudio. Sometimes when you launch your RStudio, you will have just three windows instead of 4. So the starting point is to ensure that you have all the 4 windows. So if you have 3 windows, We go to view here, view. This is panes. So we say show all panes. So here I have the 4, but you can see that this environment and this window where you have your files, plot, packages, viewers, presentation, occupy bigger space. So it's good to move it. You can see you can move here and there depending on what you are trying to do, or you move here. You can see so they're actually movable. The same apply to here and here. So this is what is called the editor window. This is where you type your scripts, particularly when you are working with long scripts. That is, you want to write many codes and run them. But if your desire is to just maybe write your code, run it at the same time, then you can use console. This is one time at a time. So let's say I have 1 plus 1. For instance, I type 1 plus 1 here. 1 plus 1, you press enter, I get my 2. But if I type it here, 1 plus 1, 1 plus 1. If you press enter, it's going to take you to number 2. It's not going to give you the results. So let's say I have 3 raised to power 3 here, 3 raised to power 3. I press enter. Here I have 27. But if I say 3 raised to power 3, and I press enter, it's going to take me to number 3, line 3 of my code. So if I want to get the result in this case, you have to highlight everything, then you run, get your results. So take notes the difference between typing code on the editor window or the console. If you type your code on the console, you have to press enter to get your results, and it's one at a time. But if you want to use the editor, definitely you will have to run the script. So to run the script, it's either you place the cursor in front like this, or you highlight maybe the line or the entire code that you want to run. If I want to run just line 1 code, for instance, I will just highlight the code in line 1 to my right. Like I run this, you can see. But if I want everything at the same time, then that is. So I hope this is super clear. So having learned this, most of the time we shall be working with this script window where we write our scripts and run. So, but before we proceed, my advice is that try as much as possible to create a folder where you are going to have your data sets, your scripts, and several other things that you'll be doing. And that is where you are going to export your results so that you have everything that you are doing in one folder. So let's create a folder. Let's create it on desktop. Let me look for my desktop. Okay, desktop here. All right. Let me use a folder. I already have a folder. You can create yours. Okay, so I call the folder I'm using, intermediate R. Okay, that is my folder. So you can create a folder in R, on your desktop or anywhere, but the most important thing is that you should know where that folder is. So let's go back to, now there is something you have to learn, and that is how to set your working directory, setting working directory. And usually, before we proceed, it's always good to add comments. So if you are adding comments, the comment is to help you to understand what you are actually doing. It's a reminder, what am I actually doing? For instance, now, anytime you want to write comments, you start with hash. The first thing we are trying to illustrate is using R as a calculator, something like that. Yeah, but that is what we're trying to use over there. Now, the next thing we want to do is set working directory. So if you want to set your working directory, you will come here, session. You can find it here, set working directory. Then choose directory. Directory is the folder. So I want to use intermediate R, that is the folder I want to use. So I click open. So the moment you have this set working directory, it has set it for me. And if you want to look at all the folder and files in the directory, then you come here, click on file. Yeah, these are the stuff there. So that's how to set your working directory. I hope that is very clear. The next thing we want to learn is how to enter data directly into R. Let's say you are not importing, you want to enter your data directly. So we are going to go through two methods. We have data entry method 1. So let's call it a name. Let's say we call it my data equals in R, data is referred to as data frame, and the code is data dot frame. You can see it. It's good to just pick it here. Now, it is advisable to just press enter. When you press enter, you can see that the bracket has been divided into two. You know, this is the opening and this is the closing of the bracket. So in between is where you are going to maybe type your the variables and the content. So let's say my first variable is age. So I'll say age equal to, I will put C since I want to deal with information from more than one person. So let's say, let us look at maybe age of 5 respondents. Let's deal with 5 respondents. So we have, let's say the first is 34, the next one is 36, the next one is 47, the next one is 32, and let's say the last one is 28. So after this, you put comma here. Then let's say the second variable is sex. So let's say C. Let's say the first person. Now you are dealing with character here. So you have to use, you have to quote it. So this is, let's say the first person is male. Okay, you can, let's say male. Let's write it in full. Let's say the second is female. And Let's say the third is female. To see what you are doing, you can move this here. And let's say the next one also is male. And let's say the last is male. Yeah. And you put comma here, still have more variables. So let's say the next variable is household size. So let's say, let me use HA size at the symbol C. So let's say the first is 5, the next is 4, the next is 4, the next is 2, and the last is 3. So the moment you have concluded this entry, one thing you can do, you can highlight everything here and run. Oh, sorry, we have omitted. You can see it's supposed to be from 8 to 12. So let's do it again. Yeah. So do it again. You have that error because of the first mistake. So do it again. Yeah, beautiful. So now to look at your result, let's go to line 13. To see your result, just type my data. As simple as that. Then you run. In fact, you can even see it here, but you run it to have the results. So this is your data set. So that's the first method. So let's move to the second method. So we have data entry method 2. So for methods, let us give it another name. Let's call it my data 2 equals, in this case, it's a data.frame. But don't put anything in the brackets. Enter. Then my data 2 equals edit my data 2. That is, we want to edit this my data 2. So if you type this, then let's run the 2. If you run the 2, it's going to give you a spreadsheet, just like Excel spreadsheet, where you can type your data. So let's run. This is what I'm saying. So in this case now, I can type directly. So for the first variable, I have 34, 36, 47, 32, 28. For the second variable, I have male, female, male, male. Then the third variable, I have 5, 4, 4, 2, 3. So then you have to change the variable name. So just click on it like this. The first one is age. Then you close. The second is sex. Close. Then the third is also size, HA size. Yeah, so the moment you have finished, then you just close this. Simple. Now, if you type my data 2, run it. Yeah, this is, I think it's faster actually. But take note of one thing. Um, in naming the columns or naming the variables, take note that we write all the names together. So it's either you write all the names together, or maybe you can put dots or underscore, but not space. I hope that is that's very clear. Yeah. So now that we have generated the data set, I think the next thing is we want to learn how to exporting data data frame. Let us call it data frame to Excel. So let us export my data to, for instance. So what you need to do is say write.csv, then my data to, pick it, comma, then the name again, my data to dot csv, run it. Beautiful. So, and if you want to be sure it's already there, my folder is intermediate R, so just double click this and check for my data to. Mine, that should be M, my, yeah, so this is it, my data to.csv. Very clear. So, and if you want to open it in Excel, then you have to minimize. Let us quickly look at that. So I can easily, I can minimize this. Then let's look for it here. My data to, beautiful. So let's just click here. Yeah, I think it's coming up. Beautiful. So this is it. So let's close it. And let's go back to our studio. So that is fine. So that's take us to cleaning the data that's how to clean data. That is the next thing we want to do. So let's say data cleaning. So in data cleaning, the first thing you have to do is you have to import that data. Import the data. I want us to use fdat. It's a data that I extracted from World Bank Enterprise data on Nigeria. So to import, you can click on File here. Then you look for fdat because it's already there. So this is this fdat.csv. Click on it, then import dataset. Beautiful. Then you click on import. Another thing you can do, if you don't want to go through that method, Other thing you can do, here you have environment, history, connection. So this is import data set. You can actually come here, and since it's CSV, you use this from text read out. So you click on this, then you click on browse. Yeah, then you look for the data. Since we already have it, don't let me bother myself opening it again. So good. Now we have our data set. So go back to your code here. All right. So now that you have imported the data, R works with two types of packages, and the packages are located in what is called libraries, and we have two types of libraries. So let me show you. So you can come here, click on packages. It's going to give us the list of packages that we already have. So you can see this is user library, but if you move down, you will see system library. Those are the two types of libraries that we have. Library. Okay, yeah, good. So here is system library. So you have system library, then you have user library. Please don't forget. So system library, that's where all the packages that came with installation are stored. So by the time you install your R, you have certain packages. So those ones are stored in system libraries. But we have contributed packages that you install based on your needs. So those ones are stored in what is called user library. So for data cleaning, we want to use a contributed package called tidyverse. And if you don't have it, you must first install it. And take note, installation is once. The moment you have installed, you have installed. There's no problem about that. So if let's say I don't have it, I will click on Tools. This is Install Packages. Then I will type the name of the package there, tidyverse. But since I have it, I don't have to worry myself installing it. So let me cancel this. So the moment you have installed, if you want to load it, so that's load necessary package for data cleaning. So if I want to load it, just a library. So you can pick it here, tidy. So the moment you are typing, it's going to come up. This is the package we need, tidyverse. So you run it. Good. So in data cleaning, the first thing we want to learn is renaming variable or column name. Okay, let's say variable name. Let's say we want to rename, let us rename size type, for instance, size type as film. Yeah, good. We want to do that. So if you want to do that, I want you to just follow what I'm trying to do. So we say f that equals f that. Now you have percent greater percent. Then we have rename. So when you are renaming, you start with the new equals to old. Don't forget that it is not old equals to new. It's new name equals to the old name. So the new name here is firm equals, the old name is size type. That's great. Yeah. So you can run it. So it will have changed size type to firm. To check that, you can just say names f that. So run. You can see it has changed it. Before, size type will be here. So that is how to do it. So that's how to rename. But don't forget is new equals to old. That equals to the next thing in data cleaning. And that is selecting variables of interest. Here we have 11 variables, but let's say we are not interested in all. Let's say we just want a few of them. So if you want to select, you go through the process of that. No, since we are selecting, we have to give it a new name because our new data frame or data set will not contain just the few variables, not everything. So let's call it f new, for instance. You can call it any name of your choice equal to f that because I want to extract it from f that. So percent greater percent. This percent greater percent is called pipe operator. That is, I have this f that. Then what do you want to do with it? In this case, for instance, I want to select. So be sure you don't mess up with the spelling. So because if you have spelling mistake, then it's going to give you error. So let's say I select firm. Let's say sales. Let's say I need label. Let's say capital. And okay, let me add size. Yeah, so sorry, let me move this a bit here. Is that right? So yeah, so let's run this. Run. Beautiful. So you can check names. F new. So run it. So you can see that this is not limited to just the few variable of interest. That is selecting. So I think we need to move to how to arrange in ascending order. So arrange observations in ascending order. Let's do that for sales. So let's f that equals to f that percent greater percent. Arrange is arrange, so arrange. So you pick it here in order to add the brackets for you. Sales, that's all. So run it. If you want to see the results, you say add f that. Add means please show me the first 6 observations. So let's run this. So let's look for okay, says it's not coming out because it's hidden here. So one thing you can do to see it clearly is you can just put dollar here. It's going to give us the list of all the variables. So let's pick sales so that we have the result for sales alone. So run. Beautiful. So you can now see that this is arranged in ascending order. So when you look at the list sales, is 22,000 here, followed by 54,000. So head will give us the first 6 observations, and tail will give us the last 6 observations. And in case you want to have, let's say I just want to limit it to 3, just say put comma here 3. You can see. So let's say I'm interested in the first 10, say 10, but that's another thing. So because you can actually select observations using this method. So this is, I hope it's clear. Yeah. So that takes us to how to arrange in descending order. So arrange in descending order. So if I want to arrange the descending order, say f that equals f that. So I have percent greater percent. So I say arrange. So let's pick it. So in this case, you see DESC. Then you open the brackets. So let's see, we use our sales. So I run it. So let's see edge f that dollar, so that we just have the result for sales. So the first 6 observations, we are seeing that this is now in descending order. Yeah, that is it. If you have tail, for instance, tail f that dollar sales. Yeah, beautiful. Good. So you have seen that the first, that is the least when we consider the sales, the arrangements in ascending, is now the last when it was arranged in descending order. So super clear. Now we move to what is called subsetting. Subsetting. Subsetting means I want to obtain a subset of my data frame. Type table f that dollar. So let's say firm, run it. So I have large, medium, small. So we have 39 observations, that is 39 large firms, 225 small-scale firms and 561 small-scale firms. Let's see, my interest is just something like efficiency of small-scale firms in Nigeria, which means I have to extract observations on small-scale firms, and that's all, and discard that of large and medium. To do that, let's call it small. Let's see, small underscore data equals fdat. I'm taking it from fdat. You have percent, greater percent. So what you need is filter. So filter firm equals small. Make sure you don't miss the spelling because R is case sensitive. So run this. Beautiful. So if you have table, for instance, fdat dollar firm, you will not have the three, just have one. Oh, sorry, small, not fdat. Small, we've changed the name, small data, yeah, small data. So run. Beautiful. You can see that for the new data that we created, everything, the observations are just on small firms, small scale firms alone. Beautiful. So that's how to obtain a subset. So you can do that if you want information for medium or that scale. That's very clear. Now that equals to what is called recoding. Recoding. Let's say table fdat dollar size. Let's pick size, for instance, size. Run it. Yeah, in this case, you have 1, 2, 3. So 1 standing for small firms, small scale firms, 2 medium scale firms, and 3 standing for large scale firms. Yes, we have renamed all that under firm, but let us use another name to illustrate how to recode them into the real names that we want it to be instead of 1, 2, 3. To do that, you see fdat equals fdat percent greater percent. So we use mutate. Good. So you give it a name. So let's call it firm size equals if else. You use this if underscore else. Yeah. If else size equals to 1, comma, then what name will you give to it? 1 is small scale, comma, if else size equals to 2, Then what name will you give to it? That is medium scale. Now I want you to pay attention to something. I've defined 1 and 2. So I don't have to add effects again, because if it's not 1, if it's not 2, it's going to be 3. So for the last option, there is no need for you to add effects. So I've just put the name in quotes. So this will be a large scale. Beautiful. That's all. So run it. So sorry. Let's pick it from here to be sure we are not missing anything. Good. So let's move to line 56. And to see the result, let's say table f that, because we have just created that dollar firm size. So this it. So run it. So as you have seen what we have just generated. Yeah. So this is how to obtain a subset. I hope it's very clear. So let's look at creating a new variable. Let's say I want to create a variable called labor productivity, LP. So let's say LP, or let's say labor productivity LP. Let's say my LP is equal to sales divided by my labor, for instance. Yeah. Okay, let's say this is the way it's defined. Although usually it's supposed to be sales less material. Let me define it correctly because it's value added. Sales less material. Yeah. Okay, I think it's materials, then divided by labor. Yeah, but to be sure of the name so that you are not missing names, you can remind yourself of names. F dot. So let's run it. Yeah, it's materials. That's all right. So if I want to create LP, I just follow that's F dot equals F dot percent greater percent. So mutate. So what do I want to mutate now? LP equals, don't forget, this is just, here you have sales minus materials. Then you have divided by labor. Yeah. So we can run this. Good. And you may want to look at the forces observation for what you have just created, and that will give us table. No, sorry, edge. Not table. Edge. F that dollar. We call it LP. So it's already there. So run. So, yeah. Super clear. Yeah. Okay. So I hope it's very clear. Yeah. And now we move to maybe the last aspect of what we want to learn, and that is descriptive statistics. Descriptive statistics. So this descriptive statistics. Let's start with the mean. That's mean. So to calculate the mean is mean. Very straightforward. So let's pick the mean here. F that's dollar. Let's say sales. Let's take it for sales, for instance. Beautiful. Yeah. So this is 130, and so on. If you want to get the standard deviation, no, sorry, let's get other types of mean. Let's say that I'm interested in trimmed mean. Trimmed mean. Trimmed mean means that I want to cut off outliers. And it depends on you, the percentage that you want to choose. You are dealing with cutting off that percentage from the lower tail and the upper tails. So mean, it is a procedure here. Mean F that dollar sales. Now you put comma, you say trim. Trim equals, then you have to select certain percentage. If it's 5%, that will be 0.05. If it's 1%, that would be 0.01. You should know that one. So I think, so let's run this and get some results. So yeah, you can see that the mean has reduced because we have cut off some outliers. That is trimmed means. So let's try and get geometric mean. Geometric mean. Geometric mean. So for geometric mean, to get geometric mean is exp. That's exponential. Let's pick it here. Then you have mean of the log. Log. Then you have f that dollar sales. So run this. So this is the geometric mean. So harmonic mean. Harmonic mean. For harmonic mean is 1 divided by mean f that's dollar sales. So let's run this. Yeah, beautiful. Then we have quadratic mean. Quadratic mean. So for quadratic mean is square root SQRT mean F that dollar sales, then you get the square raised to power 2. So this, run this. So that's the quadratic means. Now to the median. Median. Sorry. Median. So median is median. So I think that's super clear. Median. So you have if that's dollar sales, you run it. Yeah, beautiful. And mode. So for mode, we would need library. We need a package called cumstats. Stats. Yeah, good. Cumstats. Run it. So if you have that, mode is mode, but it's capital MODE. You can see it here, just pick it. So if that's dollar sales. Yeah, in that case, the value is 100 and at least 1.2 million, and the frequency is 21. Yeah, so now we move to what is called exploratory data analysis. We want to explore, we want to look at the overview of the data set, and we want to obtain all the descriptive statistics once and for all instead of picking it one after the other. So this is exploratory data analysis, commonly called EDA. That's what we want to do now. For that, we need a package. It's called smartEDA library. smartEDA. That's it. Now you are familiar with how to install. In case you don't have it, you just go to tools, then you install. So let's run it. I may want to get the general view of the data set, complete. If I want that kind of report, I'll see EXP report. Here it is, EXP reports. Then FDAT, comma, then OP underscore file, that is output file. So my output file should actually be in quotes. So let me call it fdat1.html. I'll call it any name of your choice. Then you run it. So let's wait, get until the report is out. Now the processing file will be up to 100%. to get a result. Already we are in 71%. So, and anytime you are running this, when you see that red mark, it means you have to wait. Fantastic. So this is the EDA reports. So for the EDA reports, we have the overview of the data, summary of numerical variables, distribution of numerical variables, summary of categorical variables, distribution of categorical variables. Then you have bar plots for all categorical variables. So you can see all the results here and there. So this is what we are saying. Yeah, so but this is a general overview. But you can do it stepwise so that you can have your results separately. So let's say I want to do it one after the other. So let's start with the data overview. Data overview. So for the data overview, call it a name. Let's say OV_data. So and that will give me exp data, fdats, comma, and type equals to 1. So with this very small, short, brief code, I will get the overview of the data. So let's run this. Then we have OV_data. Yeah, so this is the overview. Run it. So, sorry, let me move this here. Let me run this again so that we can see in a clearer way the data. Yeah, beautiful. So let's move up, look at the results. So my total sample size is 825. My total number of variables, including those ones that I've generated, now is 13, out of which 9 are numerical, which means I have 4 text variables. Then percentage of variables having complete cases, that's 100%, which means I do not have any missing case. It's fantastic. So that takes us to the next thing, which is the data structure. Data structure. So for data structure, let us call it st_data. And that will give us exp data, fdat, comma, type equals 2. You can actually copy what we have in line 93 then change few things. So let's run this. And let's get as st_data. Good, so run this. Yeah, so we have, it gives us quite a lot of information. So you have the variable type now coming out clearly. So you have fame as a character variable that is non-numeric, building is numeric, machinery numeric, size numeric, and so on and so forth. Then the sample size for different ones then you have a number of distinct values and so on. So you have more information here. And don't forget, you can export any of these things to Excel to see it in a clearer way by using write.csv. Yeah. Now let us look at summary of numerical variables. Summary of numerical variables, and we'll stop there so that we can continue later from there. So we have a summary of descriptive, numerical, sorry, numerical variables. Yeah. So if our interest is just to get the summary of our numerical variables, then I'll call it a name. Let's call it num_stat, for instance, numerical statistics. So equals to say exp_nu, that's exp num_stats. So let's pick this. Then you have fdat, comma. It's a rand. Rand means the decimal place I would like to use. So let me place it to 3. Yeah, I think that's all. So let's run this. Good. So then num stats. So run this. Oh, sorry. Oh, I called it mom stats. So this is num. Yeah, let's run the two together. Yeah, so you have quite a lot of information. You can see quite a lot of them. So plenty results. Now, I think we should just stop there. I think we can continue from there in the next class. So far so good. Taking us back to where we started. I think we look at introduction to R, just using it as calculator or as blackboard or whiteboard. There you set a working directory. We consider how to enter your data into R directly and how to export your data back to Excel, how to clean your data, and after cleaning the data, how to make some descriptive statistics one after the other, and how to carry out EDA, Exploratory Data Analysis. So thank you. Till we meet again. So I wish you all the best with your family. Have a nice time. Thank you very much.